Video, we'll talk about data transformation in R. I think this is going to also transform your life when it comes to data manipulation. So let's get into the learning goals for today. Um, in the last few videos, we dive deep into the ggplot2 package, which was a core package of the tidyverse. But in today's lab, we're going to talk about the dplyr package. That's really how it's pronounced, the dplyr package, which is another core package of the tidyverse that allows us to learn about and apply various data transformation tools to any kind of data set. So in this lab, we're going to be talking about a data set that is on on some flights that departed from 3 different airports in New York City. And in this lab, we'll particularly focus on some of the verbs or some of the operations that allow us to do data manipulation very efficiently. We'll start with talking about row-wise verbs that are filter, arrange, and distinct. We'll talk more about what these mean. Then we'll get into column-wise verbs, which are mutate, select, rename, and relocate. And combining all of these verbs where we are doing row-wise or column-wise operations is helping. Anything that helps with that is the pipe operator, which is which basically helps us write, and you've seen this before, it helps us write commands like we were writing a plain English, right? So it tells us do X, then do Y, then do Z, something like that. And so the pipe operator helps us combine all of the verbs that we will learn about. Finally, we will talk about how we work with groups that we can create from our data set, which when combined with, so when we combine the group by commands with some sort of a summarize command, which gives us some summary statistics, this becomes a really powerful combination. So we're going to learn about how we use group by, and then how do we combine that with summarize. And then we'll also get into how we can use, sometimes this is useful, how we can use the slice family of functions. So with that, let's get into the prerequisites for this lab. You want to make sure that the tidyverse package and the New York City Flights 13 package is installed and of course loaded. So let's get started with this. I already have this installed, so I'm not going to copy this code, but let's just make sure. I mean, you're gonna have to do that first step, but let's go back to R. Let's just make sure we can open up an R script. You can save, etc. I'm not gonna do that here, but make sure that if you haven't installed these packages, you have done that. Okay, so I'm going to load these really quick. Okay, and yes, as you can see, well, I don't know why flights just popped up here, but you can write data flights. As you can see here, flights is from the NYC Flights 13 package. So you can just click on that, and then that should populate on the right hand side. Right, so here you can see now it's sitting in your environment, and you can actually do a lot of data manipulation with it. Okay, so I don't know why this is coming up in my console, but let's get rid of this. Okay, so let's go back and see what we're gonna do today. So one of the things you can do very easily is, in your console, you can type in help flights or question mark flights, and it's going to give you a lot of information about what this data is. This data, like I said, is coming from New York City. It's flight data, and this is collected from the Bureau of Transportation Statistics. So if you're interested, you can go click on the link and kind of see what kind of data sets they have. It's actually pretty interesting if you want to just learn about different types of data sets that are out there. As we do more case studies, you might be interested in the data source and just trying to dabble in data yourself. Okay, now this is data on the data that we're going to use today is coming from of course the New York City airports that you might be familiar with. This is the John F. Kennedy, the JFK, the LaGuardia, LGA, or the Newark Airport, Liberty International Airport. And this is all of the data from just 1 year alone, which is 2013. Okay, so you can do that very easily. You can try to look at the help menu. If we type in help, notice on the right hand side, it tells us about what this data is, which package it's coming from, and it tells us what kind of variables do we have here. So we have year, month, day, the date of departure. So basically if we have year, month, day, which is basically our first column here, second column, and third column, we can figure out the date of departure, right, from those three columns. Then we have departure time and arrival time. So as you can see here, there's departure time. So 517 would stand for 517 AM perhaps, okay, and something like that. And then there are actual departure and arrival times. Yeah, so it's basically telling you what the format is. It's HHMM, so hour and minutes, or hour and minutes, depending on what we're using here. And then this is all in the local time zone. And it's also telling us a bunch of other things here. For example, if there has been a delay in those flights, whether it relates to departures or arrivals, and those are all stated in minutes. So it's very important for you to always take a look at the data that you are dealing with, what it's measured in, what the format is, what's the type of each variable that you're dealing with, etc. So here notice it says that departure and arrival delays are in minutes, and anytime those are negative, those are representing early departures and arrivals, which hasn't happened to me yet whenever I fly, but okay, there are some people who get lucky and their flight takes off early. So then we also have information on the carrier. So we can try to kind of scroll here and try to see what we have, the information on carrier. It's probably telling us whether this is a United Airlines flight or an American Airlines, a Delta, and so on and so forth. I don't know what B6 stands for here. Yeah, probably not flown that, but there is another data set, so you can actually see what those airline names are by clicking airlines. Okay, so it might tell you a little bit about what those are. It also has the unique flight number. Well, it might not be unique, but each particular row might be unique because it's for a particular date. And one flight number might only originate or fly on a particular day, right? They just repeat over time. It's the same flight number for the same time the next day, for example. And then we also have some information on tail number, etc., right? So there's all this data that we have that we can do a lot with. So I would just like you to go and check this out. There's origin and destination, which is super important, which we'll deal with. There's also airtime, the amount of time spent in the air in minutes. There's also distance. So you can see that if we have airtime and we have distance, we can do distance divided by time and get the speed of the aircraft. And we also have time underscore hour, for example, which is the schedule, date, and hour of the flight in a particular format. So anyway, there are a lot of different types of variables that we have, and we can try to work with that. Okay, so with that, let's go back. You know how to glimpse your data set, but let's just go ahead and do that here so we can see some more things, we can have some more insights into our data. So, okay, so let me pull this up here, and we can see we have about 336,776 rows and 19 columns. 19 columns are the different variables that are listed here, which we were going over on the right hand side. But you can see that year is an integer, month is an integer, stuff like that, right? So you can take a look at the type of variable, like what is the type of the variable here. Like you can see departure underscore is a double because obviously it's not an integer. And we can see that we have some character vectors, or sorry, some character variables here, or vectors is fine too. It's part of a data frame. It's just a collection of vectors. And we have the tail number, which is a vector. So you see all these things are in quotes. So we already know these are characters. R is actually not reading it as a factor, which is good for us if we ever want to deal with this data set later and we want to work with it as a factor, then we would have to make those conversions. And we have airtime, we have distance, hour, etc. These are all double. And we can see time underscore hour is sort of a date time type, okay? So anyway, this is good enough information for us for now. And let's go back and try to see, you know, when we are viewing this data, for example, let's just say view flights. I mean, we're doing that, but what's this is doing, working inherits false, invalid first argument. I don't know what that's doing, but the important thing is if we try to look at, let's say, head flights, it's going to tell us that this is a Tibble, okay? So I know you've probably seen this when we've been dealing with other data sets that, you know, this thing comes up and then you have the dimensions of the data set that are written here. It's just because I'm heading this is only showing it's only displaying the 6 rows, but it's displaying all of the 19 columns. That's just the default setting in head. But really, we have those 336,776 rows in the data. Okay. Now, the important thing is to distinguish between Tibble and a data frame. Okay. Now, Tibbles are generally a special kind of data frame, and they are only designed for large data sets. They show the first few rows and columns that fit onto one screen. So as you can see, we would have a really tough time if we just had all of those 336,000, or if we had millions of observations, or rows, those show up, right? We only want to glimpse that. And so it's a Tibble is an ideal type of data frame for that. Okay, now, like I mentioned before, the operations that you can perform on any kind of variable or column that you see in this data set depend very much on the type of data that you're dealing with. So I would just encourage you to always take a look at the structure of the data set, or glimpse the data set to look at those variables. Now, coming back to this dplyr package, which is the core package in the tidyverse, dplyr verbs that we will learn about today can do a vast majority of our data transformation. So this is a super, super useful lecture in that sense. It's actually very hard for you to follow anything in the future if you don't know these verbs, because they are that important. The only thing I would encourage you to remember is that when we are using these dplyr verbs that you will learn about, the first argument that we always want to supply to R is to tell R what is our data frame. We always want to tell R this is our data frame, and then we want to do something to it. Okay, so any kind of manipulation comes later on. Okay, so in that sense, the second step is supplying some subsequent arguments, which is, you know, usually related to the columns that you want to operate on, and or, you know, you're just supplying variable names. Okay, so you're not putting those in quotes. You don't have to, like you know from before. And then finally, it's important to know, are you just trying to display the output for yourself because you want to view something, or are you trying to store that output? And so it's important to know that whatever data frame is being created, you know, you can do something with it. Either you can just look at the output or you can store that output. Okay, so let's move on to the pipe function. The pipe function is, you know this by now. This is the base pipe function. There's also the percent greater than percent, which is in the magrittr package, which we will not use here. I encourage you to use this because this is also in base R. If you're ever working with pipe, you know, you don't really need to be in the tidyverse. You can just work seamlessly and do what pipe does brilliantly for you. Okay, so what does this mean? The pipe is, even though we'll say pipe and pipe and pipe when we're writing code, it's really the meaning or the pronunciation, even when you're talking about your code, is to say and, to basically replace the pipe with and then. Okay, so what does that mean? So if we write down something like this, where we have X, pipe, Y, pipe, Z, this just means take X, okay, take X and then do Y and then do Z, okay? So I've written this out. I've actually simplified this a lot more so you understand this is how we're going to be reading this. So it's super important that you understand that it's really just taking the thing on the left, then doing something, and then doing Y to it. And then basically this line here is saying, let's take what we have in this step and then do Z. Okay, so that's how you want to read it. And you can keep writing lots and lots of pipes with different types of manipulation tools that you will learn today. Okay, so in that sense, it lets us combine multiple verbs. So let's take an example of what we might be doing today. Okay, it's okay if you don't understand what might be going on, but it's good to just try to understand where we might be headed. Okay, just like what we did in the last video where we had a scatter plot and then we said, well, this is our goal. And you know, in any kind of visualization also, it's nice to just imagine what you want your graph to look like and then move on. So it's good to just kind of see, even though this is not a visual graph or anything, this is just some code. It's nice to just look at what we might be able to do by the end of this lab. So take a look here. We take that flights data, then we put the pipe function. So we're basically saying take flights and then filter by destination. So as you can see, we're using the filter verb here, and we are saying wherever destination equals SFO, right? So this is San Francisco Airport. So these are all the flights. Remember, the data is saying all the flights that are originating from New York, the 3 airports of New York. And we are trying to say, let's filter all of those flights that are coming to SFO. And then, right, there's a pipe here. So we're saying, and then group by basically all these date variables, right? So year, month, day combined together are basically our date variables. And then summarize the arrival delays, right? Or give us the mean of the arrival delay here, okay, by dropping the NA values. So that's kind of what we might be doing. And so you can see here that the verbs that we might be learning about today, or we will be learning about today, are filter, group by, summarize, and many more. Okay, so here we are only using these, but we will learn about many more of those. So, you know, your output might look something like this, which we don't have to go into the details of. But this was your code, and if you're interested in the slides, I also have the meaning step by step. But I think you can come back to this meaning once you have done this lab to just kind of review if you understand what's going on in this code. So now let's turn to row-based verbs, and the first one is filter, okay, which we just saw. So what does filter do? Filter is, remember, a row-based verb. So it is going to subset rows or observations in your data set based on some kind of condition or conditions on the variable values that we have, or column values that we have, okay? So what it's going to do is it's going to choose rows that evaluate to true for all the conditions that you put in filter. And like I said before, the first argument that we want to supply is always a data frame, which is our flights data frame that we're using today for this lab. And then the subsequent arguments are going to be some logical conditions. You are aware of the logical conditions that we've done before, in the more preliminary videos where we said, okay, this could be a greater than, an equal to, greater than, equal to, things like that, okay? So those logical conditions, whenever those are true, those values get filtered, right? So in our previous example, when we were trying to filter by, when we said, let's filter by destination airport, being San Francisco, whenever this condition is true, R is basically focusing on that. It's creating a subset in this step. And then subsequently, whatever manipulation we are doing is being applied to this subset, okay? We could be doing more subsetting of the data in other lines, but that's what filter is doing, okay? So you can use Boolean and logical operators that you've learned about in previous videos in the filter verb. Okay, so let's try to look at how does that work. So let's say we wanted to find out about all of the flights that departed more than 60 minutes late, right? So more than an hour late. So we know that we are talking about departed flights, and we know that we want to know about more than 60 minutes, so all the flights that are more than 60 minutes delayed. We know that in our data set, we have a variable called departure underscore delay that tells us about how many minutes those flights were delayed by. So we can write out a code to filter out all of those flights. Notice remember we had 336,000 something rows in our entire data set. Now we want to filter it out to all of those flights that have a departure delay of more than 60 minutes. Okay, so let's see what that code would look like. We're simply going to take flights, and then we are going to filter, and we're going to say what the condition is. So this is a logical condition. This is a logical condition within the filter command that is going to evaluate to true for all of those cases. And you can see the output here. The output is telling us that that condition equals true for 26,581 cases in our data set. Okay, so you can also calculate, what percentage of flights were delayed more than 60 minutes, for example, with this type of information. That would just be 26,581 divided by, the number of rows, whatever that is, 336,000 something, right? And times 100%. So you can do many things with it. Okay, now let's say we wanted to find out all flights, or we wanted to kind of look at all of the flights that are operated by United Airlines. Remember, we also had a carrier variable. So we can basically say, let's take flights, and then let's filter by the carrier. And remember, because we are dealing with a character here, the type of carrier is a type of the type of type of variable that carrier is character. So we want to make sure that we use equal to, and then we put UA, which stands for United Airlines, in quotes. So that's what we're doing here. And notice that out of those 336,000 flights, 58,665 are just operated by United. Okay, so that's what this is telling us. So it's very important not just to be able to, you know, do this kind of data manipulation or data transformation to look at what's going on, but also to be able to interpret what you're seeing, when you see these tables, and try to get more information out of it. Okay, so that was an example, another example where you could use filter. Let's say we wanted to find out about flights that departed on January 1st. Okay, now remember that we have some information on the month, and we also have the information on day. So you can imagine that now we are trying to filter based on two different types of columns. And so R is going to go row wise and check if month is equal to 1 and day is equal to 1. So let's see what that would look like. So again, we take flights and then we filter by month equals 1, and it's very important that you understand this is a combination. What we are writing here within the parentheses here is a combination of the logical conditions that you've learned about and the Boolean operators, right? So the logical condition is this evaluates to wherever it's true, that's going to be kept. And whenever this is true, that's going to be kept. And together, whenever these hold, whenever these evaluate to true, then those are the rows that would be filtered out. So notice here, when we look at the output, it's going to tell us that both of these are 1 because we are interested in January 1st, right? So at home, you can try to practice with, let's say, February 14th. Maybe people weren't flying because it was Valentine's, or maybe they were, I don't know. But, it's just interesting to see what's going on different days, for example. But that's just for your practice. All right, moving on. Let's say we wanted to figure out or filter out all of those flights that departed in January or December, right? So this is not saying and, this is saying or, right? We want to get January as well as December. Okay, so we can write our code in this way, where we have a complete condition. Remember, whenever you're using and or, this stands for or, this vertical line here. We want to write a complete condition on either side. Okay, this is a common mistake that I see in code, so you want to avoid that. And you also want to make sure there's a double equal to sign because it is written as a condition. So what do we want to do? We want to only filter by those 2 months. So we want to say wherever month is equal to 1, which stands for January, or whenever month is equal to 12, give me all of those rows, right? So that's what we're doing. Now it's possible that, I tell you, well, I want month 1 through 6, okay? A shorter method, so basically if I ask you, okay, give me all of those months from 1 to 6, there are different ways of doing it, but you don't want to keep on writing the equal to 1 through, all the way to 6 and keep, have 6 conditions with ors in between. You can kind of go for a shortcut where you can combine this, right? So remember that we had talked about the in operator, and the in operator basically evaluates is something that you have on the left on in the right hand side vector, right? So it's independently evaluating whether month is either 1 or 12 or whatever else you want to put in this vector. So this is definitely a shorter way to select flights that departed in January or December. Okay, so you want to know about, it's absolutely fine to write this type of code, but you know, if you had to scale and you had many other things to select from, then this is a much better option. Okay, so I want you to know both. Okay, let's move on. And remember that, you know, anytime we are filtering this or we are, so let's just take this, for example. Let's take this code and let's go to R. Let's see here. Let's say, forget this for a second. Let's say we were only interested in, let's say this is something related to Jan 1 flights. Okay, so for that we said month equals 1 and day equals 1, right? That's how we were filtering. And we said, let's run this. Okay. And notice here, it's telling me that there are 842 rows and 19 columns, right? When you filter out, and then you can see month and day everywhere is 1, right? So we've done this, but this is just something that's coming up in our console. We haven't really stored it, okay? So let's say we wanted to create an object, which is just called Jan1, okay? We can use the assignment operator. So look at line number 8 here. We are typing Jan1, which is a very intuitive name for an object because this data is on flights, and Jan1 would just mean maybe we are filtering all of the flights that operated on Jan 1st from New York, right? So we are doing something on the right? This is what you're familiar with, but we are just assigning all of that to an object called Jan 1st, right? So if you run this, then notice on the right-hand side, now we have Jan 1st, which is a subset of the flights data, and this only contains all of the flights that operated on January 1st. So it's important that we understand that we can create objects and save those, right? So saving the result of the filtering to a particular variable would just be populated in your environment. Okay, so that's what we have learned. So that sort of completes what we know about the filter command, or how we can use the filter command. And just kind of a reminder here, there are common errors. Like I said, when you're filtering, please do not put a single equal to sign. It will throw an error. You can try doing this, okay? There is a single equal to sign. R is going to tell you that you are making a mistake. Another common mistake, like I was mentioning, is when we are trying to say, let's filter by month, either January or let's say February, then we can't write a command like this, where it says month equals 1 or 2, because R usually evaluates one condition at a time before those Boolean operators. So you want to make sure that you're writing the code nicely, like here, where you are writing a complete condition before the or, and then a complete condition after that. And you can have multiple conditions separated by those Boolean operators. All right, so let's move on to the arrange verb. This again is something that is applied to the rows, and arrange is basically like a sort in Excel. Okay, so what it does is it changes the order of the rows based on the values of the columns, right? So you can always filter from the smallest to the biggest value, of a variable versus, or you could go from the biggest to the smallest value, right? So again, the first argument will always be a data frame, and subsequent arguments are just columns that you want to sort. If you supply more than one column name, then each additional column will be used to break the ties in the values of preceding columns. We'll see how, okay? But the default order when you use the arrange verb is just that we're going from small to big. Okay, so let's take an example here. So let's say we wanted to sort flights from the least to the most delayed, right? So we know that the delay, okay, so here we are talking only about departure delay. I should have specified that, but you know, we have the departure delay variable, and we want to make sure that it's going from the least delayed to the most delayed. As you can see, obviously I'm not showing you the code yet, but you can see here that we're going to this from the smallest value, which is negative, which means that this flight left 43 minutes early, and people get to the airport way earlier than I do. I could never even catch a flight 40 minutes early. And then you can see that these numbers are decreasing, right? So obviously there are many, many more rows, and this is our entire data set, right? Because this variable is available for our entire data set. So what does that code look like? It's actually very easy. You take the flights data and you say, and then arrange by departure underscore delay, right? So what this is doing is it's putting the data, it's sorting the data from the least to the most delayed flights. And that's what you see here. And you have all of the data available. Now, what if you were wanting to have all of those flights that had the maximum delay on top? Okay, so you want to go in descending order. It's very easy to switch that. You can get that by just wrapping DESC, which stands for descending, inside the arrange function on that variable. So notice here we are telling R to arrange departure underscore delay in descending order. And now we can see that here is, my gosh, departure delay is 1301 minutes. That's ridiculous. But I mean, I guess this is less than what the delays that we are seeing these days in the news. That's like 50 some hours or something. So this is in 2013, maybe flights were even better. I don't know, I mean, better or not, but it's was relatively better. 1301 minutes. And then this is all in descending order, right? So you can see that that there are many flights that were delayed a lot of time, by a lot of minutes. I mean, these are in double-digit hours now, but this is all in minutes, so these numbers are bigger. Okay, so that's what we've learned here: how to use the arrange verb, how to sort in ascending and descending order. Ascending is the default, remember that. Now, it's possible to sort by multiple columns. Okay, so we can sort by year first. So what it's going to do is it's going to give me the least value for year, which is the earliest year that's in the data set, to the latest year. Because we are dealing with only one year in this lab or in this data set, you know, this is sort of a redundant point, but we still want to write it down. And then if we are trying to filter by month, then it's going to, within a year, it's going to take the months that have the least value to the maximum value, right? So the earliest months to the later months. And then if we are trying to filter by day as well, it's going to look at each day within a month, and it's going to put the earliest days on top and then later days at the bottom. and then by time. So what is that? If we wanted to do that, what would that look like? This would basically mean we take the flights data and then we arrange by, first we want to do year, then by month, then day, and then by departure time. Okay, so as you can see here in the output, we have 2013, month 1, day 1, and then the earliest flight that left any of those airports in New York was at 5:17 a.m., right? It's hard to get to any of those New York airports. Nothing is closed if you're in Manhattan. If you've ever gone there, it's a mess to get there. So you probably have to wake up all night to get there and make this very early flight. But I bet it's cheap at that hour, or maybe not. It's New York. So let's go on and talk about another verb that we can actually apply to rows and columns both. But we'll see how that works for rows first. The verb itself is called distinct. Now, distinct, as the name suggests, it's going to find unique rows in the data set. Sometimes this is, or many times, this is useful when you have very large data sets and maybe there are some rows that are duplicate rows. So what it does is it just finds those unique rows in the data set, and it will keep the first occurrence and it will discard all of the other rows that are duplicate. Okay, so it's not going to discard all of the rows that are after the duplicate rows, but it's just going to discard the duplicate rows, right? And keep one of those. Okay, so that everything you have in your data set is a unique row. So this is a row-wise, it can be a row-wise function. And there are some optional arguments when we talk about how we can use distinct with column names. So we can take a look at the example with rows first. So it's very easy to do this. If you want to remove any duplicates, now in this data set there are no duplicates because you're going to get back everything here, but you can basically check that. It's always a good practice to do that. You take the flights data and then you say distinct and then empty brackets, so empty parentheses. So the empty parentheses is basically checking flights for, it's scanning like every row, and it does it in a second, right? Imagine doing this in Excel with millions of data points. Not great. Okay, so that's why we have R, which is super powerful, and it can do this in a fraction of a second. 336,776 rows are still remaining because there was nothing that was a duplicate row in our data set. Okay, so this is how we check for that. Now coming to how we can apply distinct to columns, to our column variables, we might be interested in learning about the unique combinations of origin airports and destination airports, right? So you can imagine that in our data set, you can even try to look at the data set, that there might be many destinations, right? Where the flights are going from the 3 New York airports. But however, the origin airports are only 3, like I told you before. And those are reflected here, for example. We have EWR, LGA, JFK. So we can see how to use distinct, the distinct verb, with column names to get unique combinations or pairs of those origin airports and destination airports. So all we have to do is take the flights data and then use the distinct verb on the 2 variables. So when you put these 2 variables in, R is going to spit out a tibble, which is a data frame, which has 224 rows and 2 columns. The 2 columns correspond to the origin and destination variables in our data set, but 224 is referring to how many distinct or unique pairs are there for the origin and destination airports, right? So this is just one unique combination. Here's another unique combination, right? So let's say here, number 3 is JFK to Miami. I don't know all of these, but you know, you can figure out this is Newark to Orlando. Is that Orlando? I don't know, can't remember. Or this is LaGuardia to Dulles in DC, or perhaps that's in Virginia, the airport itself, but it's still, you can try to figure out what these are, because it's very easy to Google these and find out what these are. Okay, anyway, you're seeing that if you did this, the rest of your data set doesn't show. Okay, so that's why we can take a look at how to keep other columns in our output. What kind of option can we give to keep all those other columns that went missing when we did this? Okay, so here's the code for that. All you're doing is you're doing the exact same thing up until this point, and then after a comma, you're going to give this condition which says dot keep underscore all equals true, which is going to keep all of those variables. Okay, so all 19 variables are reported, but then notice that the rows are 224, so it's only reporting unique combinations of those. Okay, and then it's possible that we want to count the number of occurrences that are duplicate. Okay, and we can use sort equals true to arrange in descending order of the number of occurrences. So let's say we wanted to find out, can we count the origin and destination pairs, and we want to sort those, right? We want to understand like how many flights are operating for those origin and destination pairs, right? So if we are saying, okay, there's a unique destination pair that is JFK to Miami, we want to count how many flights were operating in 2013 between JFK and Miami. Okay, so that's why you might want to use count with sort. Okay, so let's take a look here. Let's try to understand what this does. Let's go back to R here. So let's go here and then try to understand. We are using count, okay, with sort. That's what we're doing. Okay, let's paste this here. So we're taking, notice what we're doing. We're taking flights and then we are counting for each combination of origin and destination airport. We're trying to get the number of duplicate occurrences, right? So for all those combinations, it's going to count the number of flights. And then we're doing sort equals true. So let's just see what comes up. Okay, stay in the console, okay? Don't look at that. So here, okay, now it's saying there are 214 more rows, etc. Those are not getting printed. Here's a quick fix for that. We can say pipe, okay, and then, so right after that, we can say print, and we can say n equals, and how do I know that? Let me just show you. In the output here, it's gonna say print, use print, n equals something to see more rows. Even though it's not giving you everything, just type in infinity here, okay? This is how you type in infinity with a capital I and F, just capital I, everything else is lowercase. And if you run this, okay, it's telling me, it's giving me all of those 224 combinations, okay? And what sort is doing, sort puts the, okay, let's go further up here. All right, we have it. So we can see that the most popular flight in 2013 was, I mean, I don't know, popular flight or not, but the most frequently operated was between JFK and LAX, right? And we can count how many flights were there. 11,262 flights just between JFK and LA. I guess people like the beach, and people like the warmth in California. So that's what's happening. And again, they are going to Atlanta. They're going to, is ORD, what is ORD? Let's just check. It has to be Orlando, but I could be mistaken. Oh no, it's Chicago. I'm making that mistake again and again. But yeah, so ORD, my bad, it's Chicago. But oh, San Francisco is also a popular destination from New York. I mean, doesn't surprise me, but I expected more for SFO than LAX, but maybe things have changed. We don't know. This is 2013 data. Anyway, so plus this is not, LAX doesn't really have other airports around or close by, but SFO does. So maybe this is not an accurate representation. People can fly to Oakland, for example. Even that's going to be called San Francisco now. Anyway, so this is what we're seeing here. And sort, remember what sort is doing? It's putting the maximum number of duplicate rows for that particular combination, for that particular unique combination on top, right? So you can, if you go down, you can see, well, which was the flight that, oh, there are some ones here. I feel bad for people who live here. This is Lexington, I guess. So only one flight is operating, or operated in 2013. Wow. Okay, so there's a lot of things that this reveals, right? So that you get an idea of what we can do with this data set. All right, so now we know how to use distinct on rows, okay, on columns, and how do we keep all the columns if you want to see them, and how do we use count to count those occurrences that are duplicates. And that's useful information. Sometimes we want to remove the duplicates, and sometimes we want to count the duplicates. So it's important that you understand that. Okay, so in the next video, I'm going to talk about column-based verbs.